Welcome to Understand the Math. In this video, I'll go over how to graph the cosecant, secant, and cotangent functions in 5 clear steps. Before you begin, be sure to check out the video description below for a link to free guided notes that you can download and fill in as you watch this video. Our first step in learning how to graph the cosecant function is to write the cosecant function in terms of the sine function. Cosecant x is equal to 1 divided by the sine of x. The second step is to determine where cosecant x is undefined and has vertical asymptotes. Cosecant x is going to be undefined where sine x is equal to 0. If we look at the graph of sine x, we can see that sine x is 0 at these points. We can write this as sine x is equal to 0 at x is equal to 0, plus or minus pi, plus or minus 2 pi, and then all the points after that. This tells us that cosecant x is undefined and has vertical asymptotes at these points. So that occurs at x is equal to 0, plus or minus pi, plus or minus 2 pi, and more points after that. The third step is to determine the period of cosecant x. To find the period of cosecant x, we need to look at the period of sine x. Sine x has a period of 2 pi, so that tells us that cosecant x also has a period of 2 pi. Our next step is to find the values of cosecant x from 0 to 2 pi. We'll start with writing down what our sine values are from 0 to 2 pi. These values are 0, root 2 over 2, 1, root 2 over 2, back down to 0, and then minus root 2 over 2, minus 1, minus root 2 over 2, and back up to 0. We'll remind ourselves that cosecant x is equal to 1 divided by sine x. When x is 0, our cosecant x is going to be undefined. Our next value is 2 divided by root 2, which is root 2. And then we have 1, we have another root 2, and then we again have division by 0, which gives us an undefined number. The next numbers are minus root 2, minus 1, another minus root 2, and then another undefined. Cosecant x is undefined at 0, pi, and 2 pi, and that's why there's a vertical asymptote at those points. Let's go ahead and fill those points in. So we have a 0, pi, 2 pi, and then mirroring to the left, we're going to have an asymptote at minus pi, and then another asymptote at minus 2 pi. To graph our function, we're going to first graph the points that I'm going to put a little check mark by. So it's these 3 and then these 3. When x is equal to pi over 4, we're going to get a value of root 2. When x is pi over 2, we get a value of 1. And then at 3 pi over 4, we get a value of root 2. When x is 5 pi over 4, we have a negative value of minus root 2. And then a minus 1, and then another minus root 2. So if we connect these points, we can see that our cosecant graph looks like this, and then like this. Since our cosecant graph repeats every 2 pi units, we can look and see what it's going to look like on the left-hand side. It will look like this, and then like this. To graph the secant function, we'll begin by writing the secant function as 1 divided by cosine x. So you can see this is going to be very similar to the same analysis that we did for graphing cosecant x. We'll now determine where secant x is undefined and has vertical asymptotes. Secant x is going to be undefined where cosine x is equal to 0. And on the next page, we'll look at a graph of where that's going to happen. We can see from the graph that cosine x is going to be 0 at these points. These points are equal to plus or minus pi over 2, plus or minus 3 pi over 2, and points after that. This tells us that secant x is undefined and has vertical asymptotes at x is equal to plus or minus pi over 2, plus or minus 3 pi over 2, and all the other points. We'll now determine the period of secant x. We know that cosine x has a period of 2 pi, so that tells us that secant x also has a period of 2 pi. This is just like the cosecant function. To find the values of secant x from 0 to 2 pi, we'll first write down the values of cosine x. Those values look like this: 1, root 2 over 2, 0, minus root 2 over 2, minus 1, minus root 2 over 2, 0, root 2 over 2, and then back to 1. Our secant is going to be the reciprocal of those values, and it's going to look like this. 1 divided by 1 is 1. 2 divided by root 2 is root 2. Then we get an undefined, a minus root 2, minus 1, a minus root 2, another undefined, another root 2, and then finally a 1. We'll begin graphing secant x by putting in the points where our secant x has asymptotes. Those points are pi over 2, 3 pi over 2, minus pi over 2, and then minus 3 pi over 2. To graph the secant function, we'll graph the points from our chart that I'll put a check mark by. So we have our first 2, and then we have 3 in the middle, and then our last 2. So we'll begin when x is equal to 0, secant is equal to 1, and then at pi over 4, it jumps up to root 2. At 3 pi over 4, our secant is minus root 2. And then at pi, it's equal to minus 1, and then back down to minus root 2. At 7 pi over 4, it's equal to root 2. And then at 2 pi, it's equal to 1. Now let's see what our graph looks like when we connect these points. Since our function is 2 pi periodic, the left-hand side is going to be a mirror image of our right-hand side. So it's going to look like this. Our last function to graph is the cotangent function. We'll write the cotangent function in terms of the tangent function and then in terms of the sine and cosine function. Our cotangent is 1 divided by tangent of x, which is 1 divided by sine x over cosine x, which gives us that the cotangent function is cosine x divided by sine of x. The cotangent function will be undefined and have vertical asymptotes where sine x is equal to 0 because sine is in the denominator of cotangent x. From our graph, we can see the points where sine x is going to be 0, and we'll mark those in red. This tells us that sine x is equal to 0 at x is equal to 0, plus or minus pi, plus or minus 2 pi, and points after that. This gives that the cotangent is undefined and has vertical asymptotes at these same points. So it's at 0, plus or minus pi, plus or minus 2 pi, and all those other points. Our third step is to determine the period of cotangent x. Tangent x has a period of pi, so that tells us that cotangent x also has a period of pi. Since cotangent x has a period of pi, we'll find the values of cotangent x from 0 to pi. And we'll remind ourselves that cotangent x is cosine x divided by sine x. When x is equal to 0, cosine is equal to 1, and then root 2 over 2, and then 0, and then minus root 2 over 2, and then minus 1. Sine x at 0 is going to equal 0, and then root 2 over 2, and then 1, root 2 over 2, and then back down to 0. To find cotangent x, we'll take cosine divided by sine, so our first point is going to be undefined, and then we'll have a 1, a 0, a minus 1, and then another undefined value. To graph cotangent x, we'll first put in our asymptotes. They're going to happen at 0, pi, 2 pi. To the left, we have a minus pi, and then a minus 2 pi. We'll plot these three values from our table. So when x is equal to pi over 4, cotangent is equal to 1. And then at pi over 2, it's 0. And then at 3 pi over 2, it's negative 1. If we connect these points, our graph looks like this. Our graph is then pi periodic, so it's going to repeat every pi units. So it will look like this. Now that we know how to graph cosecant, secant, and cotangent, we can graph a times cosecant of bx, a times secant of bx, and then a times cotangent of bx. When a is greater than 1, our graph is going to be steeper than our basic graph. And when a is going to be less than 1, it's going to be wider than the basic graph. When b is greater than 1, the period is going to be shorter. And then when b is less than 1, the period is going to be longer. I would encourage you to go on to desmos.com and graph these functions and then put in sliders so that you can see what happens when a and b change. If you want to learn more about Desmos, you can go to my website and read the blog post that I have on it.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.